Today we're going to look at some different problems that required implicit differentiation, but we're actually going to take it a bit further. In this first example, it's asking me to find all horizontal and vertical tangent lines to this curve. In order to find tangent lines to the curve, we know we need to find the derivative. So this is a long problem. We have 8x plus 2y dy over dx minus 8 plus 4 dy over dx. This derivative is 0 and this equals 0. Collect our dy over dx's on one side. And I'm going through this rather quickly because we have been doing implicit differentiation for 2 days now, and should be getting good at this. Move the negative 8 to the other side, which gives me a positive 8. Move the 8x over, I get a minus 8x. We are now going to factor out our dy over dx's. When we factor out our dy over dx's, we are left with 2y plus 4. Now I'm going to divide by that 2y plus 4 to get my final answer for dy over dx. So in general, we could find the slope of any tangent line to the curve using this 8 minus 8x over 2y plus 4. Let's go ahead and find those specific ones that we're talking about. Let's go ahead and do the vertical tangent lines. We haven't done a whole lot of vertical tangent lines, I don't think any. But what would that mean? Well, that would be where our bottom is equal to 0. So what I'm going to do is I'm going to look at the bottom of the slope of the tangent lines, and I'm going to figure out where is that undefined. Well, quite simply, that would just be where y is equal to negative 2. That doesn't tell me the actual points at which this is going to occur. So all I really have is that I know it's going to be at negative 2. Now I've done this problem before, so I actually know there's going to be 2 points that come up, but let's go ahead and assume there's just one for right now. How do we get our x values? Well, we have to take that y value and plug it back in to our original question up here. So we now have 4x squared, plug in our negative 2 for our y squared, which was right here, minus 8x plus 4 times negative 2 plus 4 equals 0. That gives me 4x squared plus 4 minus 8x plus negative 8 plus 4 equals 0. Well, 4, 4, and negative 8 create 0. Factor out of 4x, and we're left with x minus 8. Oops, let me take that back. That'd be x minus 2. I already factored out the 4. Equals 0. So my x values end up being 0 and 2. So my 2 points would be 0, negative 2, and 2, negative 2. Those are the answers for the vertical tangent lines to the curve. Now I still need to find the horizontal tangent lines to the curve. So I'll go back over here, talk about where the horizontal lines would be located, and those would be when the top is equal to 0. So let's see, we have 8 minus 8x equals 0, and we end up getting 8 equals 8x, and x is equal to 1. So my x-coordinate is 1, but in order to find my y-coordinate, I have to take that and plug it back into the original. So I have 4 times 1 squared plus y squared minus 8 times 1 plus 4y plus 4 equals 0. That will allow me to solve for y. So I have 4 plus y squared minus 8 plus 4y plus 4 equals 0. 4, negative 8, and 4 makes 0. Factor out a y. I'm left with y plus 4 equals 0. So my y values are 0 and y equals negative 4. That creates 2 points. 1 comma 0. Okay, there's my x, 1, and there's my y, 0. And the other point is 1 comma negative 4. This was quite a lengthy problem. We can discuss this further together.